Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Azrin Nur Alif, and today we will learn about atomic physics. So first thing first, in this video, I'm gonna talk more about the Bohr assumption, atomic energy level, hydrogen atomic spectrum, and the line spectra of the hydrogen atom. So first, we're going to the Bohr assumption. So the Bohr assumed that the electron will move in circular orbit around the proton under the influence of the Coulomb force of attraction, and the size of the alloyed electron orbit is determined by a condition imposed on the electron orbital angular momentum, and the radiation is emitted by the atom when the electron jump from allow orbit to another allow orbit, and the frequency of the radiation emitted in the jump is related to the change in the energy of the electron. So next we go to the so this is some mathematical formula that involved in this atomic physics, and when we see in this formula, so this formula shows that the electron can only exist in certain allowed orbit determined by the integer, which is n equal to 1, 2, 3, and so on. And when n is equal to 1, the orbit has the smallest radius called as the Bohr radius, and the radius is 0.0529 nanometer. Next, we're going to the atomic energy level. In the Bohr model, an electron can jump from higher energy level to lower energy level, or vice versa. And the lowest energy level is n equal to 1 is a ground state because it was the most stable among others. The others is which is n equal to 3, 2, 4, and so on. And the other state is called as excited state. And when we see in this diagram, we can see that this is the ground state, but in this diagram the ground state is 2, so we can see that they are from 3 to 2, 4 to 2, 5 to 2, and 6 to 2, and the transition between the state require energy, which is in this formula we use the initial energy minus the final energy. And next we're going to the hydrogen atomic of spectrum. So each line has different wavelength and color, and this series is called as an emission spectrum. And in this emission spectrum there are 3 series, which is Balmer series, Lyman and Paschen series, and the energy emitted is given in equation just like the previous formula, but before we only use E initial minus E final, but in this part we use all of the formula like what in the diagram. We can see that if the electron jump to the n equal to 1, it was Lyman series. If En to En equal to 2 is Balmer and Paschen for the next. And in our level, which is foundation level, we only learn until Paschen series. But if we advance to the if we take atomic physics in degree, we will learn more about this series, and we will found bracket series. So I think that's all from me for in this video. I want to say thank you for listening and thank you for watching. Assalamualaikum warahmatullahi wabarakatuh.